Assalamu alaikum. Today on 3rd December 2025, I'm starting lecture number 13, lecture number 1 for week number 13. And the topic of today's lecture is double integration. So students, in our textbook, exercise 15.1 is basically that exercise where we learn how to perform double integration. So a very simple thing is basically you can see there are two integrals. The inner integral is with respect to dy and the outer integral is with respect to dx. So to evaluate this integral, we will basically uh, evaluate the inner integral first, and then we will evaluate the outer integral. Some students are still coming, so we will keep them uh, involving in our class. Okay, so admitting in our class. So let us again go to the exercise. So you can see in question number 1, exercise 15.1, there are two integrals. The first integral is with respect to x, which is the outer integral, integral 0 to 3 dx. The second integral is basically the inner integral. It is from 0 to 2 dy, and the function to be integrated is 4 minus y square. So uh, now to perform this double integration, I told you that first of all, we will evaluate the inner integral. That is the integral 0 to 2, 4 minus y square dy. And then after integrating this function, applying the limits from 0 to 2, then we will integrate the answer of the first integral, and then we will apply the second limits that are from 0 to 3. So let us write this question on our register, and then we will solve it for you. So it is question number 1, where integral 0 to 3 and integral 0 to 2, 4 minus y square dy dx is to be evaluated. Okay. Students, can you see my camera?
Yes,
GCSE
sir.
students.
Mm.
Okay. So now we are to perform this double integration. And as I told you, we will keep the outer integral as it is. We will not integrate with respect to the outer integral. Rather, we will integrate with respect to the inner integral first. So therefore, I inserted this square bracket to make this thing clear that our first integration will be with respect to y. Okay. So now we will keep this integral 0 to 3 as it is. And integral of 4 with respect to y is 4y. Similarly, integral of y square with respect to dy is minus y cube upon 3. Okay. Now, after integrating the inner integral, we will apply the limits that are from 0 to 2. Okay. So, integral 0 to 3. Now we will apply the upper limit. So it is 4 into 2 minus 2 cube upon 3. This is our first limit minus, let me just uh, add another student. Okay, I think yes. Okay. So coming back to our camera. So we applied the upper limit, and as I always do, I use basically a curly bracket to show that this is the upper limit of the integral minus, for the lower limit it is 0. So it is 4 into 0 minus 0 cube upon 3 dx. So you can see we are keeping the outer integral outside of the square bracket. And first of all, we integrated the inner integral and then we are applying the limits. Now we will simplify these limits. So 4 into 2 is 8 minus uh, 8 upon 5, 3 minus 0 minus 0 dx. Okay. So now it will become integral 0 to 3. 8 over 8 minus 8 by 3, we can take LCM 8, 1 into 3, 8 into 3 minus 8 upon 3 dx. And finally, it became integral 0 to 3, 24 minus 8 upon 3 dx. And then integral 0 to 3, 16 upon 3 dx. So hence we basically completed the inner integral with respect to dx is obviously 16 upon 3 x. And then we will apply the limits 0 to 3. And you know that the upper limit would be 16 upon 3 times 3, while the lower limit will be 16 upon 3 times 0. And obviously, it will become 16 minus 0, which will give us 16. Okay. So now we can confirm the answer from the solution manual. So if you open the solution manual, you can see that their answer is 16. Okay. And our answer is also 16. Okay. So it's a very simple thing to do. Uh, Performing or evaluating the double integration is not a very complex procedure. But one thing we must know that how to integrate with respect to a particular variable. For example, in question number 1, you can see that since the inner integral was 0 to 2 4 minus y squared dy, so it was a relatively easier question. Why? Because the function was solving only one variable, which was y squared. Let me add another student. Okay. So now what was the ease here? Basically, when we were performing the inner integration, we were integrating with respect to y, and the integral was containing a function which is only a function of y. So there was no complication as it was the first question of the exercise. So the author of the book basically gave a very simple question. But sometimes, like you can see in the second question, when you will integrate with respect to dy, because the inner integral is integral minus 2 to 0 dy. Now this function is not only the function of y. Rather, it is also involving the terms x square and 2xy. So therefore, when you will perform integration on these functions, you should be very careful. Okay. So we will inshallah solve some questions for you. So now let us again revise the solution of the first question. So you can see we started from there. Since the inner integral was 0 to 2 dy, so we integrated with respect to y. So integral of 4 with respect to y is 4y. Okay. and integral of y square with respect to y is y cube upon 3. Then after performing this inner integration, we applied the limits 0 to 2. So you can see first we took the upper limit, we applied it, then minus from the formula, and then we took the lower limit. So after simplifying these limits, we got finally integral 0 to 3 16 upon 3 dx, which was a very simple function to integrate. Integral of 1 is x, so integral of 16 upon 3 is 16 upon 3x. Then we applied the outer limits 0 to 3, and hence we got the final answer. So it was a very simple question. There was nothing complex in this question. But relatively, this gradually this exercise will become complex. Okay, and we need to cover first 40 questions from this exercise 15.1 as per our curriculum and as per our requirements of the course. Okay, so let us now go to the second question. So in this question, there are again two integrations because two integrals because it is obviously a multivariable integration. So the inner integral is basically with respect to y, and the outer integral is with respect to x. Okay, so let us write this question. It is integral 0 to 3 with respect to x, and then integral minus 2 to 0 with respect to y, x square y minus 2xy dy dx. Okay, okay. So now we are to perform this integration. Okay, and you can see that the inner integral is with respect to y. Okay, let me just add some students. Actually, whenever I call a meeting, I always send invitations to your official emails. So if you will be joining from there, in my opinion, you don't need to be basically admitted by me. But unfortunately, you people don't basically open your emails. Never mind. Okay, so we were solving question number 2, and you can see that first of all, we need to solve the inner integral with this, which is with respect to y. So we will keep the outer integral outside of our brackets. Okay. And then first of all, we will write the inner integral inside the square bracket to basically confirm you that we are to evaluate the inner integral first. Okay. Now, integral 0 to 3 is outside of the bracket. And now we are to integrate x square y with respect to y. Okay, in this situation, we will consider x square as constant. Okay, you must remember this thing. Okay, now we are to integrate x square y with respect to y because there is a dy here, which is indicating that this integration is with respect to y. Okay, now if we are to integrate x square y with respect to y, then we will consider x square as constant. So we will not integrate it. Rather, we will only integrate y because our variable of integration is y. So integral of y is y square upon 2. So the answer of integration will become x square into y square upon 2. Similarly, when we will integrate minus 2xy. So we will keep minus 2x as, we will consider minus 2x as constant, and we will only integrate y. So the integral of y is y square upon 2. Okay. So this is our integration. Then we will apply the limits. Okay. Now in the next step, we will apply the limits of y. So the upper limit is 0. So now this limit will be applied in y, not in x, because we integrated with respect to y. So the limits will be applied only in the y variables. So x square into 0 square upon 2 minus 2x into 0 square upon 2. This is our upper limit. Minus, for the lower limit, x square into minus 2 whole square upon 2 minus 2x into minus 2 whole square upon 2. So you can see I applied the limits only in the y variables because we integrated with respect to y, and in this integration for us x and all terms containing x are constant. So we will not apply limits in x. We will only apply limits in the y terms, in the y variables. Why? Because we integrated with respect to y. Okay. So now integral 0 to 3. Fortunately, our first bracket is 0. So it's very simple. Then x square. Now minus 2 square is 4 and 4 divided by 2 is 2. So it will become 2x square. Now this 2 will be simplified with this 2. So minus 2 square is 4. So 4 into minus, it is minus 4x. Okay. Now integral 0 to 3. 0 minus 0 is 0. And it will become minus 2x square plus 4x. Okay. Dx. So now we will integrate with respect to x because we have applied the limits of y after integrating with respect to y. So now we will integrate the remaining function with respect to x. And you can see after integration with respect to y, there is nothing in the function which is containing y. Why? Because we applied limits in the y variable. So now it is a pure x function, a pure f of x. Okay. So now we will integrate it. So minus 2 is common. Integral of x square is x cube upon 3. Similarly, 4 is common. Integral of x is x square upon 2. And then we will apply the limits of x. Okay. Now it is minus 2 x cube upon 3 plus 2 times x square, and then we will apply the limits. So first we simplified the function, and now we will apply the limits. First, we will apply the upper limit. So minus 2 upon 3 into 3 cube plus 2 into 3 square, and then we will apply the lower limit, which is minus 2 upon 3 into 0 cube plus 2 into 0 square. Okay. Now minus 2 upon 3 2 into 18, which is basic, sorry, minus 2 into 9. Similarly, 3 square is 9. So 9 into 2 is plus 18. Minus 0 plus 0. Okay. Now it is minus 18 plus 18 is 0. So again, you can confirm this answer in our solution manual. If we open the solution manual, you can see that their answer is also 0. Now, what about these sketches? Actually, these sketches are the requirement of the question. Let me just show you the statement of the question. They are saying sketch the region of integration. Evaluate question number 2. You can see that y is varying from minus 2 to 2 and x is varying from 0 to 3. Minus 2 to 0 and 0 to 3. Coming back to our camera, if y is from 0 to minus 2 to 0, so we will mark minus 2y here, because if it is minus 1, then this is minus 2. So y is from 0 to minus 2. And x is from 0 to 3. So if this is 0, then this is 1, 2, and 3. So you can see that limits of integration are basically giving us this area that is to be integrated, that is to be found. Okay. So you can see in the statement of the question, they are saying sketch the region of integration. So how we identified this region of integration? Using the limits. Our limits were minus 2 to 0 and 0 to 3. So y was 0 to minus 2 and x was from 0 to 3. Hence we identified that which region is basically is the region of integration. So sketching this region of integration sometimes become very important in finding the integrals. Okay. Now coming back to the exercise, you can see that uh, whenever we integrate with respect to a variable, suppose we are integrating with respect to x, and if in the function there are some y's, then we will uh, take those y's as constant. And when we are integrating with respect to y, we will take the x components of the function as constant. We will treat the x component as constant. So now let us solve question number 3 of this exercise. So in question number 3, we are to integrate from minus 1 to 0 and from minus 1 to 1. The function is x plus y plus 1 dx and dy. So can you tell me that whether we will integrate with respect to x first or we will integrate with respect to y? G students. Anyone who want to answer this? Okay, it's very simple thing. Since the inner integral is from minus to 1 and it is with respect to dx, so we will integrate with respect to x. Okay. So let us solve this question. Okay. So you can see the inner integral is with respect to x. So we will keep the outer integral out bracket, and then we will integrate the inner function with respect to x. So the integral of x is x square upon 2. Okay. And now y is constant. So now integral of y is yx. Why it is yx? Because if we take y common, then there is a 1 in this term, and integral of 1 is x. So x multiplied by y is xy. Okay. Similarly, integral of 1 is x. So now we will apply the limits from -1 to 1. Okay. And then we will integrate with respect to y. Okay. Now integral -1 to 0. We will apply the limits. So the upper limit is +1. So we will write 1 square upon 2. Now you can see I'm applying the limits in x, not in y, plus y into 1 plus 1. Because we integrated with respect to x, so limit will be applied in the x variables. Minus, now the lower limit is -1. So in place of x, we will write -1 whole square upon 2 plus y times -1 plus -1. Okay. So when you integrate with respect to in the x variables. Okay. So integral -1 to 0. 1 upon 2 plus y plus 1. 1 upon minus y minus 1 dy. Now we will simplify the limits. It will become 1 upon 2. 1 upon 2 from there and minus 2 plus and plus y 1 dy. So you can see this 1 upon 2 is with this 1 by 2 minus 2. We are left with plus y is 2y and 1 plus is 2. So now this integral is very simple integral. The integral of 2y is 2y square upon 2, while integral of 2 is 2y. Minus 1 to 0. Okay. So it's y square plus 2y, and the limits are from -1 to 0. Finally, we will apply the limit. 0 square plus 2 into 0 minus -1 square plus 2 into -1. Okay. Now it's 0 plus 0 minus 1 minus 2. Finally, 0 minus -1. And finally, answer is 1. Okay. So now again, we can confirm our answer from the solution manual. We open it. So you can see that their answer is also 1. Okay. The solution manual, they basically don't give you all steps, but they basically give you a basic idea. Okay. But you can see that I gave you the complete solution, that how we will perform the dx integration first, the x integration first, then we will apply the limits of x, and then we will uh, simplify the limits. We will cancel the terms that are being added or subtracted, and then after simplification, that's how we perform double integration. Okay. Let me just add some other students that joined the class. Okay. So students, a very simple to do, but since you are doing this for the first time, so you will take some basically time to understand these things. But believe you me, it's a very simple thing, nothing difficult in it. But what you must remain in keep in your mind, that whenever you are integrating with x, you will integrate only the x variables, and you will consider that the y variables are constant. And if you are integrating with respect to y, you will consider that the x variables are constant, and you are to integrate with respect to y. Okay. Now, question number 4. You can see in question number 4, we have a trigonometric function to be integrated. But one term is sine x, so it is a function of x, and the other term is cos of y. So when integrating this function, we must basically uh, take care of this thing, x as y or y as x, then it will become wrong in this question. Okay. So let us solve question number 4. So in question number 4, integral pi to 2 pi, and then integral 0 to pi sine x plus cos y into dx dy. Okay. So now this is basically the function that is to be integrated. Now let us first uh, sketch the region of integration. So to sketch the region of integration, we will draw the xy axis. You can see that dx is varying with from 0 to pi. So if this is 0, this is pi by 2, and this is pi. So x is varying from 0 to pi, while y is varying from pi to 2 pi. So if this is pi by 2, and this is pi, and this is 3 pi by 2, and this is 4 pi, 2 pi. So y is varying from there to there. Okay. So hence our region of integration will be this region. Why? because x should vary from 0 to pi and y should vary from pi to 2 pi. Okay, so this is our region of integration. Y is varying from pi to 2 pi and x is varying from 0 to pi. Okay, now to integrate this function to x. Okay, so we will write integral pi to 2 pi, then integral 0 to pi sin x plus cos y dx. Okay, now first of all we will integrate with respect to x because the inner integral is with respect to x. So integral of sin x is minus cos x. While integral of cos y will be integrating with respect to x. So if we take cos y common, then we are to integrate only 1. So integral of 1 is x. So integral of cos y to is basically x time cos y. Some students get confused here. Why? Because they write integral of cos y as sin y, because they think that we integrate cos y, but it's not correct. Why? Because we are integrating with respect to x. So for us, cos y is constant. Okay. So what we are doing, we are integrating cos y as constant. Constant with it is x times cos y. Okay. Now we will apply the limits of x. And again, if we are applying the limits of x, it will be implemented on x variable. So it will become minus cos of pi plus pi time minus cos of pi plus pi times cos of y. This is the upper limit minus cos of 0 plus 0 times cos of y dy. Okay. Now if our calculator is in the radian mod, and we calculate and 0 into cos y is 0. Okay. Really, at the limits, it is 1 plus pi cos y plus 1 time dy. So 1 plus 1 is 2 plus pi cos y. And now we are to integrate this function with respect to y. So integral of 2, while integral of cos y is sin y. So integral of pi cos y is pi sin y. and the limits are from pi to 2 pi. Finally, we will apply the limits. So 2 into 2 pi plus pi sine of pi, this upper limit, minus 2 into pi plus pi times sine of pi. It is our lower limit. Now 2 into 2 pi is 4 pi. And if our calculator in the radian mod, then sine of 2 pi is 0. 0, which is 0, minus 2 pi. And again, sine of pi is 0, so pi into 0 is 0. So finally, minus 2 pi and 2 pi. So you can see that it is a well-organized method where first of all we find the region of integration. Then after finding the region of integration, we evaluate the double integral. In evaluating the double integral, first of all, we evaluate the inner integral. And if the inner integral is with respect to x, we will only integrate x terms as variables. We will consider the y terms as constant. So after integrating with respect to x, we apply limits and integrated with respect to x, so the limits will be applied only. Then after simplifying, we function which involves y. We basically apply the limits of y since we integrated with respect to y, and finally applying the limits, we get the final answer. So again, if we are to confirm our answer, we can always check the solution manual and you can see that our region of integration is correct and our answer is also correct. Okay, so I hope that you understand now that how to evaluate the double integral and how to basically integrate different containing x and y with each other. So inshallah, in the next on campus, we will go deeper into the complex questions. So for today, since it is an online class, we keep simple. So inshallah, we'll meet you in the next class, and you must remember that in the next class, uh, fourth quiz from area and volume, that is exercise 5.4 and exercise 6.1, and this will be the last quiz of your academic semester. Okay, and inshallah by the next week we will clear the marks so that you can prepare yourself as per your midterm performance. Okay, so after stopping the video, I will take the attendance. So inshallah, then we will basically uh, our class. Okay, thank you.